Welcome back. This is Mr. Omar Minga. In the last video, we've looked about an overview of business intelligence. What is business intelligence? We looked at its why is it important, and then we looked at its historical foundation. And now let's talk about. In this video, we are going to talk about data mining. Now, what is data mining? Data mining is extract hidden patterns to predict trends and support decision making. What does that mean? In a certain load of data, you extract the hidden patterns, the patterns that you cannot see, and you detect the hidden patterns, and then it helps you predict trends. It helps you predict what would work better for the business and what would work the best for the business, and then it supports in decision making. It helps you take decisions that are beneficial to your business, and it easily integrates into current systems. Data mining can easily be integrated into any system, the current used systems, the current trends, and everything. And then it enhances data value and competitive advantages. It gives data more values because when it analyzes the data, it gives you accurate information. It gives you fact-based information, and which helps you which helps your business upgrade to a certain level whereby it can be an active competitor in the market. Let's look at types of data mining or data mining tasks. Types of data mining tasks: we have descriptive tasks, that is, it understands the past and the present. It analyzes the past. It analyzes the past and it explains the present, like based on what has been happening or what had happened already. It tells you what is happening now. And then there is predictive, which is a forecast future. Predictive is based of the analysis of the past and explanation of the present. It tells you how the future looks like for your business. And then it includes classification, clustering, association, correlation, and outlier detection. What does that mean? It includes classification. It classifies the data according to its relevance. And then clustering, which is grouping based on the classification or based on the relevance as well. And then association rule, which data can be linked to which data, or which data is related to which type of data. And then correlation, which data can relate to which data and which data can work best with which data. And then outlier detection, that is, if there is any external data that can relate to whatever you already have in your system or in your files. Let's look at association and correlation analysis. Association: find items frequently bought together, that is support and confidence material. It finds the items, like there is a certain product that when customers buy, there is another product that they usually take with this. Now this is what's called support or confidence metric. And then correlation evaluates strength and usefulness of relationships. Like for example, when people buy this product, and usually when they buy this product, they buy this as well. So it's like what's the relationship and between the two products, and the most likeliness of this product being taken when this product is purchased. And the examples are lift, and then there is something called chi-square test. What's chi-square test? It's a statistical hypothesis test used to determine if there is a difference between observed and expected data. Or it's a test that is based on assumption and it's used to determine if there is a difference between observed and expected data. Observed data is data that you monitor from the transactions, and then expected data is data that you already know is going to happen, or let's say, for example, a transaction that you know that is going to happen. When someone buys this, they will definitely buy this. And then observed data is like, when someone buys this, there is a you observing if they would buy product. When someone buys product A, then you observe if they would they take product B more, or they take product C more. Classification and regression, that's predictive tasks. Classification predict categories, like for example spam detection in email systems or whatever. Predict categories, like for example, someone buys product A and there is product B, mostly like then there is product B or product C. Some people take product B, when they take A, they take B along, and others, when they take A, they take C along. But there is one that goes relevantly with product A. Now this is a category, and then regression predicts continuous values. Like for example, sales forecast. When someone takes product A, they will definitely take product B or C along with them. That is something guaranteed, like it's known, like when product A is taken, B or C will accompany them. And then used in segmentation, risk analysis, and marketing. Role of statistics and machine learning in data mining. Statistics help in modeling, hypothesis testing, and noise detection. It helps in shaping yes, modeling, and then in assumption based testing, and then in noise reduction. Noise reduction, you predict something, you predict a certain product that will be taken, or like when someone take product A, then you predict product B will be taken or C will be taken, but then they take A, they don't take B, they ask about C, and then they think it's B is better, but then they don't take any, or something like that. That's noise. So statistics helps in reducing that. And then machine learning improves prediction accuracy via supervised, unsupervised, or semi-supervised active learning. Remember, we said machine learning is a type of AI that helps systems learn on their own. So it improves prediction accuracy through supervised active learning, which is learning through the assistance of a certain program, or unsupervised, that's learning on its own, or semi-supervised, which is both together. Yes. Data mining and machine learning. Data mining versus machine learning. Both aim at classification, clustering, and prediction. Classification is categorizing, clustering is grouping, and then prediction is forecasting the future. Machine learning focuses on accuracy. The main objective of machine learning is accuracy. It also makes sure, it always makes sure that whatever it's predicting, it's accurate. It's going, if it predicts something specific is going to happen, when product A, product C will be taken, then when product A is taken, product C will be taken. That's the objective of machine learning. Then data mining emphasizes efficiency, scalability, handling complex data. Data mining focuses on efficiency, the best state, and then scalability, gradually getting better, and then it handles complicated large amounts of data. Now, let's look at database, data warehouses, and information retrieval. Database, it's basically it's basically a base for data and data warehousing and yeah, data warehouses. Yeah, it's warehouses is a large scale storage facility. From the word, we can actually grasp something, and then information retrieval. Like there is a certain information that is stored somewhere, then you want to go and get that information. Database is query optimization or indexing. It's based on asking questions and then asking the best questions that or the relevant questions for whatever operations that you're doing in your business. That's why it's said query optimization. And then indexing is grading or numbering, systematic numbering. That's indexing. And then data warehouses, it integrates the diverse data. It takes all types of data, like same thing as the physical warehouses. You can store different type of products or different type of materials. And then it enables OLAP. OLAP is online analytical processing. That is a technology used to organize and analyze large amount of business data, OLAP. And then multi-dimensional mining. Like it doesn't have a certain direction, or it doesn't take certain direction for mining, or it doesn't take a certain systematic order for analyzing the data. It picks from different places and it goes to different direction. And then information retrieval, this is it searches unstructured data, and it's useful for text and web mining. Unstructured data is simply data that is not organized in a certain manner or in a certain way. And yes, it's useful for text, documents, this and that. And then web mining. Web is a group of or is a mix of text and then multimedia, which is audio, video, and images, and so and so. Now, let's look at the major issues in data mining. Number one, mining methodology and multidimensional mining. Like one of the issues or one of the complications is there are different types of methodologies or methods used in data mining, and then multidimensional, as I mentioned, it doesn't go to a certain direction, and it doesn't pick in a certain order. It picks randomly and it goes to different direction. And then user interactions and query languages. User interactions is different type of users with different type of perceptions, and yeah. And then query languages, there are many languages, there are many query languages. That is a bit of an issue, because someone would use a certain language, and then someone else would use a different language, and then someone else would use a different language that is long forgotten from a certain age, or from about a decade or so ago, something like that. This is also an issue. And then number three is efficiency, scalability for large data, operating in its best state, and then gradually getting better. Like yes, that's for large data, because large data requires longer period of time for analysis or for processing. And then diverse data type. Yes, we know there are different types of data. We have structured data. This is data that is already organized. Then unstructured data is data that is not organized, which we need to organize in a certain way first before processing. And then there is multimedia, and of course multimedia is images, still images, motion, and then motion pictures, and then there is videos, and then there is audios. These are all multimedia. And then there is web, and web is basically a mix of everything together. All this type of data is found on the web altogether. And then ethical and privacy concerns. Not everyone has the same intentions. Some people would have different intentions, and some people would use the systems for their own gain, for personal gain, or for inflicting harm and things like that. Yeah, that's the ethical and privacy concern. And decision support system and data exploration. Decision support system is a system that aids decision making based on modules, based on data, and based on knowledge. That's why he said it's model driven, data driven, and knowledge driven system that aids decision making. And data exploration, it's pre-mining phase using statistics and visualization to identify trends and prepare data. What does that mean? It's a phase that happens before mining. It prepares the data. It uses statistics to let's say put the data in order, and then it uses visualization, things that you can see like in form of graphs, in form of what do you call it? I can say tables or so, and to identify the trends and then prepare the data for mining. Yes, this is the end of this video, and I will see you in the next one. Peace.